Flux represents the amount of something flowing through an area. For electric flux, this is the amount of electric field going through our area. Using field lines, we can approximate the number of lines flowing out through the surface minus the number of the lines flowing into the surface as the electric flux. For example, I have this point charge creating electric field lines. If I draw a surface like this, we can see that the number of field lines going into the surface is the same as the number coming out of the surface. This means that the net flux is 0. Now if I look at this surface here, I can see that there's a net flux going out because there are more field lines going out than are going in. We have a more mathematical way to represent electric flux as well. E times A as vectors. This is a dot product, which you've seen before. So A represents an area vector that you may not be familiar with. A is just perpendicular to the area that we have and has the same magnitude as however big your area is. E is the electric field, and theta is just the angle between the A vector and the E vector. We also have an integral representation of this equation. In this case, we look at small bits of area and the electric field going through it, and then add up all of them. In this class, E cosine theta, which is just the dot product version of this, will just be a constant so that the integral actually becomes a lot easier. Now let's see if you really understand flux. Looking back at our first example, I can describe any number of surfaces I want outside the charge. As long as I don't encircle the charge, I know that my flux will have to be 0. Well, what about with a bunch of charges? Only when I encircle a charge will I actually have a net flux. So here, if I encircle the positive charge, I know I'll have a positive flux. If I encircle the negative charge, I have a negative flux. But if I encircle a positive and a negative, we can see that the flux actually would become 0. Well, what about looking at just electric field lines in flux? How should my electric field lines be oriented with respect to my area vector? Well, if they're in the same direction, the dot product equation tells me that we'll have maximal flux. However, if these electric field lines are perpendicular to the area vector or parallel to the surface, they will actually end up with 0 flux. Make sure you can work through the equations and the field line representation to understand all of these different cases.